Hello and welcome to section 6.4. The topic this time is slope-intercept form of a linear equation. So far in this unit, we've talked about what is slope, as well as how do the slopes of parallel and perpendicular lines compare to each other. This topic, 6.4, might be the most important topic heading forward into pre-calculus and foundations math classes. So you want to really make sure in this section, if you have any questions, please ask about it. I want to make sure you guys have a really good understanding of this as we move throughout the rest of this course, but more importantly into future courses as well. So slope-intercept form is the most common form of writing a linear equation. A linear equation is an equation that would create a line if we graphed it. So here we have an example of a linear function on the right. It's the graph of a bicycle journey, distance from home on the y-axis, and time in hours on the x-axis. So it asks us what's the y-intercept of the graph at right. Now looking at this graph, some people like to draw a y here and an x here, although technically this is d right now for distance, and this is actually a t-axis. But in a regular sense of an XY graph, the vertical axis is the y-axis. So it's asking what's the vertical intercept. And that means where does it cross? And that is this value right here. So we have to figure what that is. And that is halfway between 0 and 20. So that's 10. But we also want to put units on that. So it's 10 kilometers is the correct answer. Don't forget your units as you're writing all of your answers in this section. What does that represent? Well, that's telling us that when the time was 0, the person was 10 kilometers from their house. So it's representing the starting distance of the bicycle journey. Oh my gosh, my spelling today. There we go. Or my typing, actually. So what's the slope of this line? Now, we want to figure out the rise over the run. And so I always recommend that you draw a triangle on your graph to help you. And so I'm going to draw in blue. I'm going to make the line a little bit thicker so we can really see it. Great. And I'm going to start somewhere where it's easy to draw a triangle from and end somewhere where it's easy. So I've now drawn a rise and a run. There's lots of different triangles you could have drawn. You could have chosen to draw this one. Okay, doesn't matter. You just pick a triangle and draw it where you can clearly see the rise and the run. And we're going to label what they're worth. So on this one, the run is the distance from here to here. So that went from 0.5 hours to 2.5 hours. So that was a total of 2 hours. So if you count that, yes, it's 4 blocks, but every block is worth half of an hour. So that's actually representing 2 hours. Here we have 4 blocks again, but that's representing going from 20 to 60 kilometers. So the rise on this was 40 kilometers. Okay, so when we go to find the slope, we have to take the context into account, which means we don't say it's 4 squares over 4 squares. We have to say it's 40 kilometers over 2 hours. And then when we divide 40 divided by 2, we get 20. And our units are kilometers on the top and hours on the bottom, or 20 kilometers per hour. Now, if you've taken driver's ed, you know that different speed limits are expressed, or speeds are expressed in kilometers per hour. So that actually helps us answer this next question. Just by looking at the units, we can tell we're talking about a speed. So the slope represents the speed of the cyclist. Write an equation to represent this linear relation. Okay, and this is where this whole section is heading, is toward writing equations. So we know that the distance that the cyclist goes is going to be equal to 20 kilometers per hour, which is their speed, times however many hours they went for, which means times the time, plus you have to add 10 kilometers to that because they started at 10 kilometers. Another way you could write that is just D equals 20t plus 10 if we were writing it without units. And underneath this, I'm going to say D was on our y-axis, so that could be replaced with the y. T was along the x-axis, so that could be replaced with an x. And then the y-intercept, we're going to start using the letter B to represent y-intercept. Sorry, I'm just going to erase the 20. The 20 represented the slope, and we use the letter M for slope. So in the future, this is actually slope-intercept form when it hasn't been filled in. This is also slope-intercept form. This is also slope-intercept form. Okay, truly our answer is these. But what I'm trying to show you is it follows a pattern of y equals m times x plus b. Okay, let's see if that pattern holds on the next example. So example 2 is about car rental costs. So along the bottom of the x-axis, which in this case is the d-axis, we have distance. Along the y-axis, we have cost in dollars. Looks like the starting cost is $60, and then it goes up from there depending on how much distance the rental car is driven. So what is the y-intercept in the graph at right? That's this value here, which is 60, and we have to put units on that. That's $60, not 60 minutes, not 60 kilometers, it's dollars. What does it represent? That represents the starting cost or the base cost of renting a car. Even if you don't drive it anywhere, if you just want to sit in the car and not go anywhere, it would still cost you $60. So this is the base or starting cost of renting the car. What is the slope? Okay, we're going to do the same thing we did last time by drawing a line. And I want to find some spots to start my triangle here. So I want to pick some nice spots. I'm not going to pick this one because I'd have to estimate. I want to pick spots that clearly kind of fall along intersection points. So those are nice clean points. That's I'm going to choose those. And so I'm going to draw my triangle or my rise and run going between two clean points. So the rise here is 2 squares. We went from 80 to 120. So it was $40 of raise. The run was going from 100 to 300. So that was a 200 kilometer run. So when we calculate the slope, and I'm going to use M for slope this time just to show that M is the letter we can use for slope. The rise was $40 and the run was 200 kilometers. Okay, and when we actually divide that, we get, did I do that right? 200, yeah, and 40. Yeah, just want to double check my numbers before I go too far. So 40 divided by 200 is 0.2. So we get $0.2 per kilometer. Now, it seems funny to say it that way because when we're talking about money, we always show 2 decimal spots. So I'm going to add a 0 on there to show the context that it's actually 20 cents per kilometer is our slope. So what does that represent? Its slope is always some kind of a rate. Last time it was our speed. This time it is the cost to drive the rental car per kilometer. And we're going to finish by writing our equation to represent this linear relation. So this time, actually I'll type to begin with. The cost is equal to 20 cents or $0.20 per kilometer times the distance plus the base cost, which was $60. So, and again, if you were writing this just kind of simplified and without units and just looking at the number pieces and the letter pieces, this would be C equals 20D plus 60. Or if we look at it in the more general sense of following that pattern that every line does, it's also the y-axis equals 20 times the x-axis plus, sorry, let me rewrite that. It's the slope times the x-axis plus the y-intercept. So it does follow that pattern where 20 is the slope and 60 is the y-intercept. So that takes us to this big box here. And this is probably the most important concept of the entire course. The equation of a linear function can be always written in this form, y equals mx plus b, where m is the slope and b is the y-intercept. So if you're ever asked to write the equation of a line, you need to know two things. You need to know its slope and you need to know its y-intercept. And if you know those two things, you can write the equation following this pattern, y equals mx plus b. So here are three examples. We've got example A, example B, and example 3. And I love this example. I think it is the most important example in the course as well. If we know that a line has a slope of 3/5 and a y-intercept of -4, that means we're going to write it using this pattern, start with the y, put our equal sign, then we have to put in our slope, our m value, which was 3/5, then I have to put the x, then I have to put the y-intercept, which in this case was -4. So instead of writing plus -4, I just write -4. For B, the equation is going to be y equals -7/3 x. This time it's a regular 5 or a +5, +5, so I'm going to write +5. In example C, we're given the equation and asked to write the slope and the y-intercept. So the slope is whatever's in front of the x here, and that is the 1/2. And the 3 is +3 as the y-intercept. Now, to analyze these a bit further, what would their pictures look like if we were to graph them? So I'm going to zoom in a little bit here. We're fairly zoomed in already, but just to make it even bigger. When we go to graph this one, we always start by graphing the y-intercept because it's the one point that we know for sure is on the graph. And so this y-intercept is -4. So I'm going to start at 0, 0. I'm going to go down 4. 1, 2, 3, 4. So that is this represented by this point. Now from there, I need to find the next point. It's kind of like a treasure hunt. Well, the next point is going to be a rise of 3 and a run of 5 away. So I'm going to rise 3 and run 5. Then I'm going to do the same thing. Right? Rise 3 and run 5. Now, I have 3 dots here. 2 dots is even enough to draw a line, but 3 gives me confidence that I'm doing the right thing here. It's making a linear pattern. I'm even going to put a 4th point. I'm going to go backward. So following this pattern backward, I'd do it in reverse, and I'd go down 3 and to the left 5. And I can even do that one more time, and I end up here. So now I have even more points to go ahead and draw my line. So I'm going to go ahead and do that. So here's the line, and it should go through all of these points. So that's what that line looks like. And then to finish it off, I'm always going to put arrows on my line unless it tells me that for some reason the line doesn't go on forever or there's some kind of restriction. That would be the answer for the graph of that function. Okay, let's take a look at the next one here. So this time we have a y-intercept of +5. So I'm going to start at 0, 0. I'm going to go up 5. 1, 2, 3, 4, 5. So that came from this value. From there, these are my directions. I'm going to rise -7 and run 3. So I'm going to go down 7. 1, 2, 3, 4, 5, 6, 7. I went down because it was negative, but I'm always going to the right. 1, 2, 3. There we go. I'm going to do the same thing. Down 7, over 3. So there's another point. I could try to go up 7, but I end up off of the grid. So I'm kind of running out of room there. I'm just going to go ahead and sketch my line. This was a little thick. I'm going to take it down a notch. And I'll do this one in blue. Okay. So there's this line. Just try and fix it a little bit there. And I'm going to put my arrows on to show that it goes on forever in either direction. Here's our last one, and it has a y-intercept of 3. So I'm going to go up 3 to graph my y-intercept, and then my slope tells me to rise 1 and run 2. So rise 1 over 2, rise 1 over 2, rise 1 over 2, rise 1 over 2, so on and so forth. So I got lots of points. I'm also going to pattern it backward. So along that same pattern to continue my line to the left, but I'm going down 1 and 2 to the left. Okay, so here is our last line. And I'm going to pop The arrows on there as well. So it's fairly easy to graph these lines once you know the equation, but you'd be surprised how many people come to Pre-Calc 20 or Foundations 20 and they've forgotten this, even though it's quite simple. So we want to make sure we do lots of practice with this. Start by graphing your y-intercept, then go ahead and use your slope to find additional points. Okay, I'm going to zoom back out a little bit so we can take a look at the next example here. So this is example 4, writing the equation if you're given the graph. So basically the backward version of what we just did. Okay, so let's take a note of the important parts of our graph. First of all, the y-intercept is very important. So that means our b value here is -4. On this graph, I'm jumping around a little bit, but here the b value is -3. Okay, so that's half the work. Now we got to figure out the slope. So from there, how many did I go up or down and how many did I go over? It's pretty hard for me to go down here because I'm running out of grid space. I'm going to go to the left and I'm going to go up. But I know this has a negative slope. So what I need to do is look for another point that's clearly on the grid. And this is my next good point to look at. I could also have chosen this one. This one's not so good. You'd have to estimate. This one's not so good, but this is a good choice. So here is my triangle. So the rise here was 1, 2, 3, but it was actually a -3. It dropped 3, and we went to the right 2. So the run was 2. So this one, the slope is going to be rise over run still, which is -3/2. So my equation, remember, is always going to be in the form y = mx plus b. I'm going to put in -3/2 for my x, and I know my b value is -4. Okay, taking a look at this one, I already know the b value. Now I want to find the slope. This one's going to have a positive slope because it's going up as we go to the right. I find the next nice point, and here it is. So that one rises 1, 2, 3, 4, and runs 2. So this one, the rise over run is 4/2, which we can simplify down to just be 2. There's no point writing 2/1. Just with final answers, we want to make our answers as simple as possible. So again, we're following the y = mx plus b pattern. We know that m is 2, so we say 2x, and then the y-intercept is -3, so we're going to end with saying -3. So our equation is y = 2x minus 3. And for some reason, I had a mistake on my answer key, so I'm just going to quickly fix that. But we have the right answer on here. Okay. Excellent. On to the last page of examples for this section. So a few word problems. Example 5. The student council sponsored a dance. A ticket cost $5 and the cost for the DJ was $300. A, write an equation for the profit, P dollars, on the sale of T tickets. Honestly, I think they meant R for revenue because profit is what you make after you take away your expenses, but we'll just roll with it and pretend that profit and revenue are the same thing. So our profit would be equal to, well, $5 times the number of tickets, 5T, plus the $300. Oh my goodness. Student council sponsored dance. A ticket cost $5 and the cost for the DJ was $300. Pardon me. We're going to subtract $300 here. I think I wrote a plus initially, and I did in my notes too. Oh my goodness, Miss Tang. So yeah, we're losing $300 because we have to pay that to the DJ. All right, so let's figure out what happens if 123 people purchase tickets. Okay, so how much money are we going to make? Are we going to make any money even? Let's see. So we're going to put in our values here. So our profit is going to be $5 times the 123 tickets that were purchased, but we have to subtract the $300 for the DJ. So the profit here is going to be P equals, and when we multiply 5 times 123, we get 615. And we're going to take off $300. And so we get a total profit of 615 minus 300 is $315. Okay, so this dance would have made $315. And you know what? Let's go ahead and circle that. It's a final answer. Please, as you're working through your assignment, it's good to circle those, especially when you've calculated something. Now, let's suppose the profit was $350. How many people bought tickets? So we're going to do the same kind of setup, except this time the profit was $350. So we're going to put $350 in the spot of P, and we're going to solve for the T value, or the number of tickets. So my first step of solving this equation, I want to get T by itself. I'm going to add $300 to each side to get rid of that. So that leaves us with $650 on the left equals $5 times T. Now I'm going to divide each side by $5. And I'm going to finish my equation up here. So 650 divided by $5 is 130. So 130 equals T, but it did ask us in words, so we should probably have answered these both in words. So for back to B, I'm going to say the profit was $315 when 123 people bought tickets. And down here, when the profit was $350, that means 130 people bought tickets. Could the profit end up being exactly $146? Justify your answer. Well, if $300 is always going to be the cost of the DJ, and we're selling tickets for $5 each, I don't see how we could make exactly $146. It's not a multiple of 5. So we could make $145, or we could make $150, but we can't make $146 exactly. So we are okay here to say no. But we have to give a reason. So when it says justify your answer, that means state a because. So it's no because then the profit must be a multiple of 5. In other words, it must be divisible by 5 to yield a whole number. We don't sell parts of tickets, we sell whole tickets. Okay, example 6, using the equation of a linear function to solve a word problem. This is kind of similar to the last one. So to join a local gym, Kareem pays a startup fee of $99 plus a monthly fee of $29. Write an equation for the total cost, C dollars for n months given at the gym. So the cost is going to be equal to however many months he's there times the monthly fee. So it's going to be that $29 per month times the number of months plus the $99. Suppose Kareem went to the gym for 23 months. What's the total cost? So that means n equals 23. So we're going to solve the equation we just wrote by putting a 23 in place where the n was. So $29 times 23 is $667. Plus we have to add on that $99. So the total cost would be $766. Suppose the total cost was $505. For how many months did Kareem use the gym? So this time they're telling us the answer and asking us to solve for the number of months. So I'm rewriting my equation with the 505 in the place of the cost and just an n to represent the number of months. To solve this one, I'm going to start by subtracting $99 or subtracting the y-intercept from each side. That leaves me with $406 on the left and 29 times n on the right. So 29 times something equals 406. So to figure that out, I'm going to divide 406 by 29. Of course, I'm technically doing that to both sides of my equation to find a final answer. And my n value is going to be 406 divided by 29, which is 14. So again, we should probably answer both of these in complete sentences because they were word problems. So back to part B, the total cost for 23 months was $766. And here our sentence would be, Kareem used the gym for 14 months when it cost $505. Could the total cost be exactly $600? Justify your answer. Okay, so we're going to need a because here. Well, let's see what happens if we put in $600. Does it work out to be a whole number of months or a decimal number of months, I guess is the question. So we're going to do this very similarly to how we did part C. It's just we're going to put in 600 instead of 505. And we're going to see if we get a whole number answer or not. So same thing, I'm going to subtract $99 from each side. That leaves me with $501 on the left equals $29 times n. I'm going to divide both sides by $29 and see what kind of answer I get. And I get an n value of 17.275 ... So people don't charge you for partial months. They work in whole months generally. So no, the cost could not be exactly $600 because you get charged for entire months, not partial months. Okay, that takes us to the end of this section. Again, a very important section for foundational knowledge about lines and graphing lines. Lines, lines, lines. They come up a lot in future math classes, and you're expected to know how to graph them or write their equations just like that. So please ask away if you have any questions. Good luck with the assignment, and make sure you are really, truly understanding things before moving on. And if not, please, again, ask for some help. Okay, thanks everybody. We'll catch you next time for our next video, which will be on a different form of equations for lines. Thanks.